So make it fast. And there are the two wrong marks are there. I want to know what is the reason. Satvik. Satvik. Umesh. So what is the first question? If n biscuits are distributed at random among n beggars, find the probability that particular beggar receives R biscuits. And the next question, if k is chosen at random in the interval 0 to 5, find the probability that the equation have real roots. The chance of an event happening is the square of the chance of the second event, but the odds against the first are the cubes of the odds against the second one. Find the chances of each. Yes. Sorry, I think there is a network issue. Is it coming? What happened to this network? Yes. Is it coming now? Is it okay? Yes. Let us look at the first question. What is this one? If n biscuits are distributed among n beggars, find the probability that a particular beggar receives R biscuits. Particular beggar receives R biscuits. So number of ways of distributing the total biscuits. So first biscuit can go to n people, second one can go to n people, third one can go to n, because there is no restriction. So it will be n to the power of n. Okay. So a particular beggar should get R biscuits, and rest of the n minus R biscuits can go to the n minus 1 beggars. So a particular beggar means he is known to us. It is not like one beggar is one particular beggar. No, it's a one identified person. So this fellow will receive R biscuits in one way, and the remaining n minus R biscuits will go to n minus 1 to the power of n minus R. Okay. Now, if for example, that particular beggar, instead of particular, one beggar need to get, means you can go ahead with NC1 because selecting that particular beggar in one way. Okay. So what exactly answer is given? Answer is given NCR 1 power. Okay. So NCR means here the biscuits are which R biscuits we are giving, we need to check it out. So which R biscuits? So the biscuits are different. So they are taking here NCR. Okay. See, what is this explanation is, you required R biscuits to a particular beggar, but out of N biscuits, R biscuits in how many ways? NCR ways. So that beggar will get in 1 to the power of 1 way only. So no need to write that one. Okay. Now, remaining n minus 1 beggars will get n minus R biscuits. So first biscuit will go to n minus 1, second one n minus 1, third one. So n minus 1 to the power of n minus R, but total number of ways will be n to the power of n. Total number will be this. So a particular beggar is there, but instead of particular, find a probability that one beggar getting this one. So you need to select NC1 also from that also, one particular beggar. Okay, but it is particular beggar, so this is not required. And moving to the next question. K is chosen random. So what is the chance actually? K is chosen random from the interval 0 to 5. Find the equation of the probability having the real root. So delta should be, what is delta? B square minus 4 into 1 into, so K plus 2 should have the real roots. So this is k square minus k minus 2 greater than or equal to 0. K minus 2 into k plus 1 greater than or equal to 0. Either k is less than or equal to minus 1 or k is greater than or equal to 2. So favorable interval is 0 to 5. So total interval 0 to 5, favorable is this one. So when the continuation data is there, probability is equal to favorable length by total length. So what is the favorable length? 0 to 5. It is a 5 units. But what is the favorable? Negative is not possible. 2 to 5. What is the favorable length? 3. So answer will be 3 by 5. Okay. Umesh, what is your problem? You're showing the negative wrong number. If what is the problem, you tell me. Otherwise, I'll keep you in the wait room. At least I'll understand what is the thing. Otherwise, I'll remove you. Because every time that is showing me, I'm thinking that new person have a problem. Umesh, are you there? Umesh Reddy, K. Umesh Reddy. Yes, Raj Siddharth.
Sir, favorable events are 4 now, sir.
Favorable events 4. How 4 beta?
2, 3, 4, and 5.
2. No. I'll give 2.1. Will you get the, did they mention K is the natural number?
No, sir.
Okay. So if you
Okay.
take that, that will be total will be 6 and 4. If they say K is the integer belongs to this one, at that time answer will be yes. 4 to 6 will come. But here they said all the real numbers of K. So favorable length by total length we need to take. Huh?
Okay. Okay, sir.
Yeah. Umesh. Okay, I'm putting you in the waiting room. And I'm making you join. Now I think you should get. Yes, Uday? Your voice is not coming better. Siddharth? Uday, your voice is not audible better. Right. So not only that one, if this is the total area, this is favorable area. So probability of such things is probability of A is equal to favorable area by total area. If it is a volume also, favorable volume by total volume. Okay. Fifth question is the chance of an event happening is square of the chance of the second event. But the okay, probability of event 1 is equal to x. Probability of E2 is equal to x. Okay, chance of an event happening is square of the chance of event. But the odds against the first one, odds against x1 square by 1 minus x1 square. Okay, is equal to odds against the second one. Odds against, not odds in favor. I have written odds in favor. Odds against means 1 minus x1 square, failure by success, is equal to cube of this one. So 1 minus x by x whole cube. So 1 minus x into 1 plus x, this one, by x square is equal to 1 minus x into 1 plus x square by x cube. Okay. So what happened? X cannot be equal to 1. X cannot be equal to 0. X square plus x is equal to x square plus x plus 1 is coming. Something we missed out. where we missed out. Calculation did we? Everything is getting cancelled. No? No. Just a minute. So what they are asking is, chance of event happening is the probability of E1 is equal to probability of E2 whole square. So probability of E2 is equal to X. Probability of E1 is equal to X square. Okay, but odds against the first, odds against of E1 against. So what is this one? Probability of E1 bar by probability of E1 bar. You are the cube of the probability of E2 bar by probability of E2. So probability of E1 bar is 1 minus X square by probability of E is X square. Probability of E2 is 1 minus X whole cube by X cube. Cancel here, X will be there. X into 1 minus X into 1 plus X is equal to 1 minus X into 1 plus X square. 1 minus X cancel. X plus X square is equal to X square plus X plus 1. Yes, Sunat?
Sir, on the RHS, you're writing expansion for 1 minus X cube, sir, not 1 minus X whole cube.
Oh, okay.
We can directly cancel.
Yes. Yeah. This is X into 1 minus X into 1 plus X is equal to 1 minus X whole cube. Yes. So X square plus X is equal to X square minus 2X plus 1. X square cancel. X is equal to 1 by 3. Okay. So find the chance of each. What is the 1 by 9? What is? So probability of E1 is equal to 1 by 9 and the probability of E2 is equal to 1 by 3. Right. Right. Dependent and independent. Here one thing better, I am covering the theory completely and just you prepare for this week. What is the exam for this week? Accordingly you follow, but I'm going to cover up everything. Okay. So dependent and independent events. Dependent and independent events. So actually dependent, independent is just you read this one, leave it, because later when you are going for the probability of A intersection B, there we'll understand more clearly. Just let us look at this one. Independent events. Events A and B are said to be independent if the occurrence or non-occurrence of one does not affect the probability of occurrence of non-occurrence of the second one. Okay. See, if you're tossing a coin between you and your opponent, so if you're winning, automatically opposite person will be losing. So here what happened? the event of you winning is depending on your opponent losing. So they are not independent, they are dependent. Okay. So independent means what happened, whether one event is occurring or non-occurrence of a particular event should not affect the occurrence or non-occurrence of the second event. Okay, just read all these 3 points. So what is this one? Two people holding a normal dice and the other one is a coin. So one is the dice and the other one is a coin. Throw them once, getting 6 on the normal dice, getting a head on the coin. So these two are independent because you can get any one of the 6 numbers of dice is completely independent of the whatever you're getting on the coin. Okay, so these are the things are there. So a ball is drawn, color noted. The ball is replaced with the other one, getting the red ball. In the second one is also independent. See, for example, you are picking the 2 or 3 or 4 balls are there. No? You are picking one ball here and then you are not replacing this one. If you are not replacing, the probability of getting another ball will be depending on this one. Otherwise, it will be independent only. Okay. So simple thing what you need to remember for this one is, for the independence and the dependent one is very simple. What you need to do is whether it is occurrence of one event is affecting the second one or not. That's only the concentration we need to do. But mathematically, what we will do is later part we are going to study. If probability of A intersection B is equal to probability of A into probability of B, then we call events are independent. Otherwise, no. And most of the people says, sir, if A intersection B is a null set, they are independent. Never. Because A intersection B is null set means occurrence of A is completely preventing the occurrence of B. So it is not independent. Okay? Right. Yes. Addition theorem of the probability. Addition theorem of probability. What is this theorem is? Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. It is simply if number of elements in A union B is equal to, you know this formula, set theory, number of elements in A union B is equal to n of A plus n of B minus n of A intersection B. Now look at here, you have a sample space where the total number of sample space is equal to n. This is A, this is B. A, B. So what is the probability of A? Probability of A is equal to n of A by n. Probability of B is equal to n of B by n. Probability of A intersection B is equal to n of A intersection B by n. This is already we know. So you divide with the sample space, number of elements in sample space. So clearly what is happening? A probability of A union B is equal to probability of A plus probability of B minus probability of A intersection. This is straight away with the set theory, because n of number of elements in A union B is equal to number of elements in A plus number of elements in B. Since number of elements in A intersection B is coming twice, you need to subtract once. This is usual way. But here some sub-theorems are there, I'll explain. The first one is, if B is subset of A, then probability of A minus B is equal to probability of A minus probability of B. Do you agree this one? Why? Because in the set theory only you look at, this is A, this portion is B. A minus B is this one, right? That. And the second property is required. What is the second property you need to do is, if A intersection B is a null set, probability of A union B, probability of A union B is equal to probability of A, 1 minute. Okay. So probability of A plus probability of B. Why? For this one, you look at here. A is here, B is here. They are disjoint sets. What you call when they are A intersection, disjoint sets. So A union B means this plus this one only. Yes? So by using these two, I'm going to write like next one. So what is this? A union B. A union B. What is A union B? Look at here. This is A union B. Can I write A union B as A union of B minus A? B minus A is, this portion is B minus A. Now these two are disjoint sets or not? Yes, because A is here, B minus A. So therefore, probability of A union B is equal to probability of A plus probability of B minus A. Now what I'll write is probability of A plus B minus A. This is B minus A. So I'll write probability of B minus of A intersection B. See better. This is A, this is B. So this portion is, I can say B minus A, or I can say B minus A intersection B also. Now A intersection B is subset of B. So I can write it as P of A plus P of B minus P of A intersection B. Maybe in intermediate, they may ask this proof. For us, only the statement matters. Only the statement matters. We are not keen on this. You can go ahead with this one, set theory, or you can go ahead with this thing. Okay, please copy. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Did you get any information about the reopening, etc.? No. Okay. But all of you get ready with your preparations and everything. Okay. Please don't complete theory once we can't do questions. See, sometimes what is the thing? No? Most theory is not that important than the problem solving. See, for permutation combination probabilities, understanding the problem and solving the problem is important. Theory is only theory. That's why. Okay. Here, part model of the questions are important. Some questions, whatever theory is important because there won't be much models of the questions. Okay. Yes. Shall I go to the next page? Right. So this is addition theorem of the probability. Okay. So A union B, and you need to be perfect with your set theory only. Okay. Right. A union B is mutually exclusive, means A intersection B is 0, then you'll be getting this one. P of A union B is equal 1 minus this one. Okay. So, right. Please do this question. And I'm telling you, no, Compared to permutation combination, probability is much easier. Because in permutation combination, we are not sure what is the answer, etc. In probability, answer will be always between 0 and 1. If some answer you are getting negative value or greater than 1, that means you went wrong. Okay? Yes. What is the De Morgan's law? Set theory you study, no? That is this one. Why you want that De Morgan's law here? Like A union B whole bar is equal to A bar intersection B bar. A intersection B whole bar is equal to A bar union B bar. Okay. So completed. Set theory not even introduced for us. Arre beta, basic set theory you should know na. You should know basic set theory beta. Don't complain those things, okay? So this question is, two students Anil and Ashmo appeared in an examination. The probability that Anil will qualify exam. So probability of A passing the exam is 0.05. Probability of B, Ashima qualify the exam is 0.1. Probability that both will qualify is, probability of A intersection B is 0.02. So you take this one. Universal set 1 only. So this is A, this is B. So A, B, common point is 0.02. So this is A. From 0.05, 0.02 is gone. So 0.03. And this is 0.08. So this total value is how much is coming. So probability of A union B is equal to 0.3 plus 0.2 plus. So it is 0.13. So this remaining portion, what is the remaining portion? So the remaining portion is 0.87. So probability of A union B whole bar is 0.87. Both Anil and Ashima will not qualify the exam is this one. At least one of them will not qualify for the exam. At least one of them is not qualified. So both of not them qualify or one of them is qualified. So probability of A is not qualified and B is qualified, or probability of A qualified and B is not qualified. You require this one. Okay. So at least one of them is not qualified. So otherwise you theoretically write at least one of them not qualify means you can write A qualified but B should not qualify. This is the case. You just go ahead with the calculation, normal, 0.02. So A qualified but B not. Or B qualifies and A is not qualified. Or both of them are not qualified. Okay. So this is equal to, what will happen? It is simply 1 minus probability of A intersection B. So probability of at least one of them not qualified is equal to 1 minus both of them qualified. So it will be 0.98. Only one of them will qualify the exam. Only one of them means it is probability of A intersection B bar plus probability of A bar intersection B. So this portion plus this portion. So what is that one? 0.11. Okay. So here set theory means very simple. What is A union B? How we will write? What is A intersection B? What is probable? Means okay, A set. When I'm talking about set, the P will not come. So P is coming in the denominator. Next one is what is A minus B? What is B minus A? What is A delta B? A delta B means A minus B union B minus A. This is A delta B is equal, which is equal to also A union B minus A intersection B. Okay. So this is a basic set theory. Maybe set theory will have the problem. State students, state syllabus students, they have the set theory. There is no problem. Only CBSE people might have faced the difficulty. So just I ask you to go through that book quickly. So not that difficult to go through also. Don't worry. Okay. You'll, once you read, automatically you'll understand. Right. Moving to the next question. Yes, Srijan? Yes, Srijan. Srijan, tell me. Please speak little louder. It's not audible. Yeah, tell me now. Only one of them qualified. Either this portion or this portion. So this is point not 2. This is totally point not 5. So what is this point? Point not 3. This is point 1. So this is point not 8. So this and this will be the answer. Probability of B is given as 0.1. No. What is how to find P? Oh, intersection B, na. Okay, probability of A intersection B. So the probability of A intersection B, they said no. The probability that both qualify is 0.02. So that is the thing. Okay. Right, please do this question. Okay. So what is this one? A and B are two events. P of A is 0.03, P of B 0.1, P of. Find the probability that exactly one of the events occurs. So this is A, this is B. The common part is 0.16. So what is this one? 0.3 minus 0.16 is 0.14. Okay. Clearly there is a printing error there. Why clearly printing error is A intersection B is subset of B. So P of A intersection B is less than or equal to P of B. But here 0.1, 0.16. So what I will do here, small correction. What I'll do is, I will take 2. Okay. So now we can do this one. So what will happen here? A, B. So common part is 0.16, 0.14. This is 0.04. So probability exactly 1, either this one or this one. So the answer will be 0.18 will be the answer. So exactly one event means A union B minus probability of A intersection B. Okay. So before getting into the conditional probability, what I suggest is let us try to solve some of the basic questions. Then we'll go for the more questions. Okay. Yes. So the conditional probability, we have enough time. So let us look at the questions. Yes. Please solve the questions. In my laptop, I have completely downgraded the brightness. I hope you people are okay with this one, no? You people, it is not affecting you people, right? Brightness with me adjusting in my laptop is not affecting. Okay. Please solve 4 questions, and after that one I'll explain. Yes. So quickly, I'll explain these 4 questions so that we can go to the next set of questions. Okay. So the first one, a quadratic equation. A quadratic equation chosen from the set of all quadratic equations, which are unchanged by squaring their roots. The chance of the chosen equation has equal roots. So there is an equation like x square minus alpha plus beta into x plus alpha beta is equal to 0. X square minus alpha square plus beta square into x plus alpha square beta square. So both should be same. So alpha beta is equal to alpha square beta square. So that means alpha beta is equal to 0 or alpha beta is equal to 1. Next, alpha plus beta should be equal to alpha square plus beta square. Case 1, alpha is equal to 0. At that time, beta is equal to beta square. So you will be getting 0 comma 0 is a 1 root. Alpha is equal to 0. Beta is equal to beta square. Beta is equal to beta square. So beta is equal to 0. Beta is equal to 1. 0 comma 1. Next. Similarly, 1 comma 0 will be there. Now alpha beta is equal to 1. If alpha beta is equal to 1, so what is the thing you'll get? 1 comma 1 is also equation. If alpha beta is equal to 1, so this is alpha plus 1 by alpha is equal to alpha square plus 1 by alpha square. So here it is this one. Now alpha is equal to minus 1, beta is equal to minus 1 will not work out. So you have the 4 chances. So the chance that you choose an equation has equal roots. This is 1, this is 1. 2 roots. So 2 out of this one. 1 by 2 will be the correct answer. So out of 4 possibilities, 2 are favorable. Is this one is the right answer? Key is also given to you people. Yes, A is the correct answer. Next question is, okay, please take it. Second question is, 5 persons enter the lift cabin on a ground floor of the 8th floor building. Suppose that each of them are independent with equal probability can leave the cabin at any floor, starting from the first. Probability that all the 5 persons live at the different floors. So total number of ways is first, second, third, fourth, eighth. So 8 to the power of 5 possibilities are there. Now you need to choose 5 floors out of 8, and these people can say come out of that one in 5 factorial ways. Means first floor, second, third, fourth, fifth, sixth, seventh, eighth. So you need to select 5 floors. So that can be done 8C5. And who is going to live, we are not sure. So that can be arrangement into 5 factorial. So there are the 2 questions, right? Right. M and N are the numbers between 1 to 100. Probability that this one is. So here what is the thing is 7 power 4. Actually, what is this one? 7 power 0 is 1, ends with 7 square ends with 9. 7 cube ends with 3. 7 power 4 ends with 1. Okay. So 7 power, it is a periodic with a period of 2. So 7 power, what is the thing? No. 4n, oh, 7 power 1 is 7 is there, no? Yes. 7 power 4n ends with 1. 7 power 4n plus 1 ends with 7. 7 power 4n plus 2 ends with 3. 7 power 4n plus 3 ends with, oh, this is 9 and 3. So you can select 2 numbers here such that it will be divisible by 5. You can select these 2 also to divisible by 5. Okay. So do the third question. Please shade the also if possible with the ink. With the ink is not possible, Nana, because the problem is I can write now in the OneNote, but OneNote is not accepting properly. That's why it is not. Okay. Sir, when we'll get the concept clear of all the chapters? If you study, you'll get the things, Nana. Okay. And once you come to the college, no, you can ask the doubts when you have whichever the doubts you have, you can come to us during the study hours personally and you can ask. Okay. So once the college opens, most of your basic simple doubts will be addressed. Yes. Will you share these questions? These questions already there in OneNote beta. Write in notability and share the link. Notability is not there with all the people, no. Notability is only for Apple. It is not available with all other people, no. Yes, Satvik.
Sir, if you share notability link, sir, if we type in browser, sir, the copy and paste we will get, sir. Phoenix sir is telling that like only, sir, sending assignments.
In notability, that link will be come to you.
Yes, sir.
Okay.
Also open notability, sir. And up there will be share link, sir. There on.
Okay, just let me try. Yeah, meantime you solve these questions. I'll try. Okay, this is one note. Sorry, notability. Create a public link. Oh, you have to sign in and other things better. Okay, if not, is there any? Okay, let me see. Let me see. Okay. For me, this is not the paid version actually. I've taken the initially, but it was not that good. So I removed the subscription. Okay. I don't know. I need to check anyway. I'll do that. Okay. Yeah. Is it visible to you people now? Right. So what is this one? 7 power m is like, if it is power 4k, it ends with 1. 4k plus 1, it ends with 7. 4k plus 2, it ends with 9. 4k plus 3, it ends with 3. So number divisible means you can take this combination and this combination. Okay. So you can take the answer. Divisible by 5 means when you add up these two, 1 and 9, end with 1 and end with 9, you'll get 0. So it is divisible by 5. So to divisible, what is the condition for divisibility? The last digit must be either 0 or 5. So m and n are the numbers. So 4k from 1 to 100. So each one is possibility of 25. This one, these are 25 numbers, these are 25 numbers, and these are 25 numbers. So 100 C2 ways you can take numbers. Now 25 C1 into 25 C1 or this into this. So this is equal to 2 into 25 into 25 into 2 by 100 into 99. Okay. If we take, will you be getting the any answer nearly? So is there any term is missing? We need to check it out. So there is the, you need to, when you're writing, you need to be very careful whether you are following everything or not. So here the important thing is m and n can be any numbers. The integers m and n are chosen at random. So only one thing is whether repetition is allowed or not. M and n need not be same. So the first number is, okay. What is the first number? What is the next one? But why I feel the answer is straight away this. You may ask why. So let me just check what is the answer is given. Third question. Is my guesswork is correct? Third question, answer is A. So what I have done here, third question, I didn't go for anything, just I went for m. I choose all the numbers from 100. Any number I choose. One way I am choosing. So when I'm choosing one way, the 7 power n maybe ends with this one, or maybe ends with this one, or maybe ends with this one, or maybe it ends with this one. Now I have this. So if it is ends with this one, I don't have any choice than going for these 25 numbers. If it ends with this one, I don't have the choice than picking up this one. If it is ends with 9, I don't have any choice than picking up this one. So for n, you have only 25 out of 100. So it will be 25 by 100. So is equal to 1 by, what is the thing? 4. So you may ask, sir, why you first step you are when you are writing 2 into 25 into 25 into 2 into 199. Here the thing is, I am not repeating. M and n can be anything. Same numbers also possible. So it is not so. First one is 100 ways. Second one is 100 ways. Now, first one is 25 C1 ways into 25 C1 ways into, what is the thing? This into this 2 ways, and m and n are interchangeable. That one is 2. So 25, 4 into 100 will be there, this one. So instead of going for this calculation, what is the first choice? I am taking m as my wish without worrying anything. And based on I'm applying the condition for the second round. Okay, that is the answer. Next one is, there are 10 prizes, 5 A's, 3 B's, 2 C's, placed in identical sealed envelopes for the top 10 contestants in the mathematics contest. The prizes are awarded by allowing winners to select an envelope at random from those remaining. When the 8th contestant goes to select the prize, the probability that the remaining 3 prizes are 1A, 1B, 1C is. So the total number of ways, 10 factorial by 5 factorial into 3 factorial into 2 factorial. This is the total number of ways. But 8th contestant, so first 7 contestants have selected 4 A's, 2 B's, 1 C. This can be done in how many ways? 7 factorial by 4 factorial into 2 factorial into 1 factorial. Will you be getting the answer? Let us look at what is this one. 7 factorial by 10 factorial means this is 10 into 9 into 8. 4 factorial means here 5 will be there. 2 factorial cancel, 6 will be there. This one cancel 3 ways. This one cancel 3 is equal 1 by 24. Something is missing. Do we have that 1 by 24 is not there? So something you need to rethink about this one. So what is the 8th contestant? So what is that one? Total number of prizes are there. So number of ways are giving those prizes. Okay. See, total number of first person will have this identical sealed envelopes. Identical sealed envelopes. Each one will be on the top of the envelope is very similar. So what is the possibility? He can select how many ways we can distribute. The first one can select any of these one. So in how many ways the first one is selected? Can we go ahead with 10 factorial by 5 factorial into 3 factorial into 2 factorial or not? So first one can select any of these one in the thing. How we can go about that one? Just to think, please. So identical things arrangement will be same or not, you need to look at here. So there are 1, 2, 3, 4, 5. Yes, are there 1, 2, 3. These are there, this. But when you look at this one way only, all are same way. But at end of the 8th contestant, the moment 8th contestant comes, so here this one should be remaining, here it should be remaining, and here this should be remaining only. What is the possibility? So just to go for this arrangements ways, you will be getting the different answer. And luckily, we cannot make the mistake as that option is also not there. So when you are taking this one, no, in the mathematics, the major problem is repetitions. Those are the repetitions, how those things are coming, we need to be careful. So 4 factorial means this is 5. 2 factorial will be means 6. 5, 7 will be there. 8, 9, 10. So where, when you are doing this one, where we are making the mistake, there should be some mistake, no? Otherwise, we would have get the answer properly, perfectly. Yes. So prices are there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually internally they are A, B, 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 C, C. Look at here. First 7, how many ways we can give it to them? First 7. 5 A's, 2 B's. 5 A's, 3 B's. 5 A's, 1 B, 2 C's. Are 4 A's, 7 should be given, right? 7 only we need to give. What happened? I can give 5 A's plus 2 B's, one case. First 7 people, how they are taking. Second one is 5A plus 1B plus 1C. This is the second case. 5 A's plus 2 C's. This is the third case. Next one is 4 A's, 2 B's, 1 C is one case. 4 A's plus 1 B, 2 C is the another case. Next one is also there. What is that one? 3 A's plus 2 B's, 2 C's. Okay. But what is the next one is also there. What is that one? 2 A's, 3 B's, 2 C's. So actually 1, 2, 3, 4, 5, 6, 7 cases are there out of 7. Which is our case? 4 A's and 2 B's. This one should be there. 1 out of 7, but that is also not there. Seems to be I'm going in the wrong way. Anyone got the answer? So this is also I'm struggling actually. They have given answer as 1 by 4 beta, but looking at this one also, this answer is not. Oh, there we need to distribute to the people also, right? Cha. Okay. I think something. Yes, Uday? Your mic. No, mic. So I'm trying for the simple way, I'm not getting. So maybe we need to look for the proper approach. So I have 5 A's, 3 B's, 2 C's. Okay. These are the things. Out of this, how many ways I can give? Okay. So first 7 people should get 4 A's, 2 B's, 1 C. Yes, Uday, your mic is riding.
Sir, now it's coming, sir.
Yeah, it's coming.
Yes, sir. So you asked that how to select 7 prizes, distribute 7 prizes to the 8 contestants. No, sir. 7
Huh?
prizes.
7 prizes to the 7 people only. And I should left
Yes,
out
sir.
with
Remaining
1
and-
A, 1 B, 1 C should be left out.
Yes, sir. So
Huh.
means we can take a 4-1 or 4-1-2, sir. The options on are 4-1 or 4-1-2 because all are filled, no, sir. Means one can only get 1, no, sir. Means 8th contestant will only get 1.
No, the 7 1, 2, 3, 4, 5, 6. 7 contest. You mean to say 7 contestant will come 4 to 1 ways. Actually, we did with 7 factorial by 2, 4 factorial into 2 factorial into 1 factorial.
Yes, sir.
And now, out of 10 people getting all the items, no? Number of ways of 8 people. Because when the 8th contestant get this one, they are asking.
Yes, sir.
Okay.
Means before it will be having this many probabilities, no, sir. Probabilities.
No,
Sorry, permutations.
this is not the problem. Yes. By
Permutation.
denominator, what you'll write? What is the denominator you'll write?
Total number of that one. 10 factorial by.
Yeah. 10 factorial by 5 factorial into 3 factorial into 2 factorial.
Yes, sir.
Now here what is happening? When you cancel this one, 5 into 6 by 8 into 9 into 10 is coming. Huh?
I'm getting answer as 4, not 4. 1 by 4 only I got. 1 by 4
No,
I
this
got.
is what you get. No? Did I make any mistake here?
By 2.
No. You are getting same thing, right?
Yes, sir. 1 by 12 I'm getting, sir. No.
1 by 24, beta. 33 is 1 by 24.
Yes, sir. 1 by 24.
I'm getting also 1 by 24, but they have given us a 1 by 4. So just I'm thinking, is there any, are we making the mistake or these people made the mistake? Just I'm worrying. Okay. Because here logic is simple. What we are doing, 7, these are the items I need to distribute to 7 people, and out of this one. Okay, I'll see this question better because I'm not sure whether their answer is correct or my answer. As per us, we are getting 1 by 24. Okay.
Sir, we need to multiply with 3 factorial, no, sir, again.
Why 3 factorial?
Means arranging that 3 members, 3 envelopes. That one. We need to again multiply with 3 factorial, sir.
No, 3 envelopes. Why 3 envelopes? Not required.
Sorry.
No. ABC,
So ABC we need
envelopes,
to
no?
take, no,
Not required, I think. Okay, I'll come back to that question. Okay. Now, this question you look at. Do the 5th question. What is the name of the book? Which book, beta? Which book you are talking about? This is not the textbook, Nano. Yeah, just I got one idea. Let us look at the previous question. One idea. See, 7 people gone with 7 prizes. Now 3 people are there. What are the possible cases out of 5? Is case 1 is 3 A's left out. Case 2 is 2 A's plus 1 B is possible. Case 3 is 2 A's plus 1 C left out. Case 4 is 1 A plus 1 B plus 1 C left out. Case 5 is 2 B's 1 C. Case 6 is 3 B's. Case 7 is 1 B plus 2 C. So I think this answer is not properly correct, beta. This answer is not properly correct. I think I need to go for this one. But here also 1 by 4. See, these are the possible cases, no? So 7 people have taken out their prizes. Now 3 things are there. So 3 A's are 2A, 1B, 2A plus 1C, 1A, 1B, 1C, 2B, 1C, 3B. This one only possible. Okay. So then in this case also 7 cases. 1 is favorable. That is also not coming. Maybe I need to think a lot. Okay, you try 6, 7, 8. Meantime, I'll try from my side. Okay. Aditya, what is that symbol you are showing? Where I'm missing 5 A's, 3 B's, 2 C's, 7 people. Okay, I'll just I'm working. You do the 5th, 6th, 7th. Somebody is suggesting me to Google it, sir. Not required, beta. Okay. And just let me understand the question properly. Okay. Don't worry about it. Google is not required for us. Okay. So we are getting 1 by 24, but your answer is 1 by 4 is there. So 1 by 24, 1 by 4 means you people are saying 3 factorial additional is coming from where the 3 factorial is coming. Maybe that one, because of this one, identical sealed envelopes. Identical sealed envelopes. There should be some specialty here because they mentioned 5 ways, 3 ways, and 2 identical envelopes is the making the difference here. Just wait, I'll come back to that. Yes, fifth question. Probability of A bar is given, probability of B bar, probability of A union B. So this is probability of A. Okay. They use the independent. So just you write this case, Nana. A and B are independent. Probability of A intersection B is equal to probability of A into probability of B. Just you take this logic for time being. If A and B are independent, this is the logic. So here probability of A is equal to 0.3. Probability of B bar is equal to 1 minus A. Probability of B is equal. Why? Probability of A plus probability of A bar is always equal to 1. So from here you can write probability of A 0.8 is equal to 0.3 plus 1 minus A minus 0.3 into 1 minus A. From there you'll get the A value. Okay. A determinant is chosen at random from the set of determinants of order 2 with elements 0 and 1. The probability that a determinant chosen has a value non-negative. So a 2 by 2 is there. Here how many matrices are possible? Total possibility 0 or 1 only. So here 2 ways you'll write, here 2 ways you'll write, here 2 ways you'll write, here 2 ways. So total matrices or denominator will be 16. And the probability chosen as non-negative. So chosen non-negative. Here 1, 1 I'll take, here 0, 0 I will take. Next one is 1, 1, 0, 1 I will take. Next one 1, 1, 1, 0 I will take. Okay. Apart from this one, anything you take, because the principal diagonal element should be, because here it is 1, maximum principal diagonal, this one 1, and minus 0 should come, because what is this one? Oh, non-negative. So 0 is possible. So 0 is possible means 0, 0 you can add from here, and 1, 0, 1, 0 you can take, 0, 1, 1, 0 you can take this one. So non-negative means total minus negative, otherwise total minus negative. Total minus negative means you take 0, 1 here, or 1, 0 you can take, or 0, 0 you can take. And here 1, 1 comes, negative will come. So how many such things are there? 1 minus negative portion also will give us the answer for this question number 6. Question number 6. Next one, 7. A license plate is 3 letters of the word followed by 3 digits. Yes, please try. 5th, 6th, any doubt? 5th and 6th, any doubt? Please. Yes, Aditya.
51, sir. I am getting 1 by 7.
You are getting
1 by 7.
which question?
51.
Huh?
51, sir.
Fourth one, huh?
Fifth question, sir.
Fifth question. So
Yes.
what are the answers for fifth question? Fifth question answer B and sixth question answer is D. Fifth question B, 2 by 7 is there. Oh, this answer you are not getting the fifth one is you are not getting 5 by 2 by 7. Okay. Okay. No, few people are getting 4, you are getting already they are saying. So, okay. Otherwise, look at here. A union B is pointed. So probability of A bar intersection B bar is equal to 0.2. So independent. So 0.7 into probability of B bar is equal to 0.2. So A is equal to 2 by 7. You'll be getting straight away. No doubt. You'll be getting 2 by 7. So here, instead of doing that one, probability of A union B is this one. You can go for probability of A bar intersection B bar. So probability of A bar intersection B bar is equal to 1 minus probability of A union B. Because independent, you can proceed with this. Next question. I think this one you will be getting 13 by 16, I think, because here what are the negative values I'm looking at? 0, 0, 1, 0, 0, 1, 0, 0, 0, 0, 1, 1, negative, 1, 0, 1, 1, 0, 1, 1, 1. I'm writing this determinant is 0, so you will not take this one. This is not. This determinant is negative. This determinant. So these three need to be eliminated. So you will be getting 3 by 30, 36 by 6, sorry, 13 by 16. Next one is a license plate is 3 letters word. Followed by 3 digits. All possible license plates are equally likely. The probability that letter plate has either a letter palindrome or digit palindrome or both. So what is the palindrome means? It is like ABA. Number palindrome 636. Okay, so probability of letter palindrome. So 1, 2, 3. So first one you can take 26 alphabets.